Hey, what's going on, everybody? Welcome back to Civil Engineering Academy. My name's Cody. Let's go ahead and get started. So today we have a FE problem. Here's what the question says. A hemp rope, which is basically like the classic little twine rope. It's not little, but it's just a classic rope that you may be picturing in your head, and pulley are used to lift a 120-pound bucket of sand. For the condition shown, what is the tension P required to lift the bucket? Let mu equal 0.3. Assume the pulley is locked against rotation. So step number one is understanding what this question is asking. So basically, how much force is it going to take to pull that 120 pounds up? You're pulling the pulley. Here's your arrow right here. You're pulling your pulley like this. How much force would it take to pull that 120 pound bucket of sand? So here's our four options available to us in pounds, and the way that we need to think about this is really almost like the relationship, right? It's almost like a belt friction type of problem. If it's just the relationship of how that works. So if we are looking in the FE reference handbook, we need to be looking in version 10.2, and this is going to be on page 110. Again, it's belt friction. Let me fix that up there. It's going to be under statics and belt friction. Okay. And whenever you look on that page, you're going to find a formula that looks a little bit like this. F1 is equal to F2 times E, and then we're going to raise that E to the mu times theta. So that's what that is. I'm going to go ahead and identify what those are. F1, it actually labels it in the handbook, so I encourage you to check out that handbook, pull it up next to this video, and follow along. F1 is the force applied in direction of impending motion. So think about this, it's our force right here that we're pulling against it. We're pulling in the direction of the impending motion, right? We're wanting it to go towards us. We're pulling the weight towards us on this pulley, right? And the weight is going to go something like this. We're wanting to pull it around and towards us. Think about it that way. F2 is the force applied to resist the impending motion. Well, we just defined what our impending motion is. It's pulling towards us. Well, that 120 pounds is going to be the force acting against us. That's F2. All right, so that's that. Mu is the coefficient of static friction, so that's given to us in the problem, 0.3. And theta is the angle of contact between the surfaces expressed in radians. So let's see here. Well, it actually gives us 220. So we have our contact surface is here, right? So it's contacting the pulley at this point, okay? And then it's contacting until eventually it reaches the other tangent, right? The other point where the rope is no longer touching the pulley. So that's what that means. That is theta. So it gives us 220 degrees in our problem. Well, we're gonna have to work that out right now. Let's go ahead and do that. That's our only unknown. We're given we have to solve for F1. We're given F2. We're given mu. We need to solve for theta. That's our only unknown. So theta is going to be in radians, right? We need to make sure we convert to radians. So 220 degrees. We need to convert this over. So we need to multiply that by 2 pi over 360 degrees. So that's just the relationship you need to know. 2 pi is 360 degrees. So we're just converting it. It's almost like feet to yards, right? That's the way you need to think about this. This is going to be equal to 3.8397, and that is radians, right? All right, so now we need to plug and chug. F1, we don't know that. We're solving for that. Is equal to, let's see, 120 pounds. Remember, that's F2. That's our force against our motion. We're going to multiply that by E, and then we need to raise that E to our mu, our coefficient of static friction, 0.3. And then we need to multiply that by our angle of contact. That's 3.8. We just solved for that, 3.8397 rads, okay? And make sure you write out your units. It'll help you. It takes maybe a couple more seconds, but it could save your tail later down in the exam. So it looks like this guy is going to be 379.71 pounds. So if we go over to our answers, it looks like it's going to be D. Hope this video helps. We'll catch you next time.